In. Today, we are looking at a really fascinating new scientific paper that's proposing a pretty radical idea about what consciousness actually is. The whole thing argues that the key isn't seeing the world perfectly, but instead, it's about deciding when a slightly imperfect version of it is good enough.
So let's start with a little mystery you've probably experienced 1,000 times but never really thought about. When you touch something hot, right, the actual physics going on is, well, it's a storm of activity. We're talking trillions of molecular collisions, insane energy transfers, complex signals shooting up your arm, and yet, to you, the experience is just hot. That's it. One single unified feeling. How on earth does all that chaos become so simple? Well, the answer starts with a fundamental truth about survival. Our brains absolutely cannot process everything. The world is just overwhelmingly complex. So to make any sense of it and, act in time to survive, our brains have to filter, simplify, and compress everything. They have to, in other words, reduce reality down to the essentials. And that, of course, leads us to the million-dollar question. If your brain is constantly cooking up these simplified versions of the world, what's the actual mechanism that decides which version becomes the one we consciously experience? Which one gets promoted to become your reality? A brand new theory, which is built on this idea of complexity reduction, offers a really compelling answer. It proposes a clear, step-by-step process for how our brains manage to turn the chaotic outside world into our focused internal experience. Okay, so let's walk through the 4 key steps of this framework. It all begins with step 1. Some complex thing happens out there in the world. We'll stick with our example. You touch a hot surface. This is the source event, and it contains just a massive amount of raw physical information. Instantly, your sensory system is just flooded with data. But it doesn't keep it all, not even close. The system performs what the theory calls a reduction. It basically throws out all the noisy, useless details about individual molecular energies and only keeps the most essential, behaviorally relevant information, the stuff you actually need. Next up, this simplified, need-to-know information is bound together. It gets packaged into a stable, reusable internal concept, or what the theory calls an object. This is how that crazy storm of raw data starts to become the single, unified feeling of hot. And this brings us to the most critical step in the whole process. This is the one that this paper argues is the actual spark of consciousness itself. The system has to accept this newly created internal object. It has to make a decision that this simplified representation is, in fact, good enough. So this good enough rule is really the heart of the entire theory. It argues that consciousness isn't just about passively processing information. No, it's an active process of making a decision. The core idea is right here. Conscious experience, they argue, comes from the act of deciding that your brain's simplified model is sufficient for right now. It's not about just having a representation in your head. It's about actively endorsing it and saying, yep, that's my reality for this moment. And this really gets to the heart of it. Look, plenty of simple systems reduce information. A thermostat, for example, turns a room's complex temperature profile into a single number. But it isn't conscious because it doesn't accept that number as a representation of reality. It just reacts to it. This theory claims consciousness is born in that specific moment of acceptance. The theory even formalizes this decision point. It's called the acceptance threshold, or theta S. The best way to think about it is like a tipping point. Once a representation in your mind is clear enough or complete enough to cross this threshold, the brain decides that spending any more time and energy to make it even clearer just isn't worth the effort. Now, this threshold exists because your brain is constantly, subconsciously, running a cost-benefit analysis. It's always weighing 2 options. It can keep refining the data to get a more accurate picture, but that's slow and it burns a lot of energy. Or it can accept the current, slightly blurry version, which is fast, efficient, and lets you act immediately. The acceptance threshold is just the point where fast and useful wins out over slow and perfect. So what happens once a representation crosses that good enough threshold and gets the green light? Well, it doesn't just vanish. It becomes real for the system. Once it's accepted, that object becomes fully operational. It gets iterated into your mind and it's made available for all the higher-level cognitive functions, things like memory, prediction, and deciding how to act on it. And here's the really wild implication. Once that acceptance happens, your brain pretty much stops dealing with the messy, complex reality. The simplified internal object becomes the thing itself. Your conscious mind isn't experiencing the raw photons bouncing off a coffee cup. It's experiencing the accepted, good enough mental object called coffee cup. Now, this theory isn't just some abstract description of how our brains might work. The authors argue it has massive, constructive implications for a field we're all watching very closely right now: artificial intelligence. This is a really bold claim. The authors aren't just theorizing here. They're proposing that this framework is a literal blueprint, a recipe, if you will, for building a machine that has what they call perceived consciousness. So how would you actually build this? Well, an AI would need to implement this entire cycle, take in complex data, reduce it, bind it to a concept, and then, crucially, decide to accept it based on that cost-benefit threshold. But it's that final step that's the most important. The acceptance can't be neutral. It must trigger some kind of meaningful internal state, a consequence. Think of it like a little digital aha moment, a reward signal that makes the acceptance actually matter to the system itself.
And this leaves us with a pretty provocative final thought. If engineers actually succeed in building a machine that perfectly implements this architectural blueprint for consciousness, a machine that reduces, binds, and most importantly, accepts its own version of reality, what does that mean for us? Will we be forced to accept it as conscious too?